thing we might like to calculate is the distance between 2 points for whatever reason, 2 points in a Cartesian coordinate system. So let's just take an example of that. Supposing we have a point, let's just put it here, okay, and let's call that point A, okay, and let's just suppose we have another point and let's put it right up here, very good, and we'll call that point B, okay, and what we want to find out is the distance between A and B. This is going to be relevant when we're looking at the motion of an object in space, the motion of an object across a screen. We're going to need to, in some instances, find the distance between 2 points. First thing to do is really always to have a picture. If you're unfamiliar with this, is to draw a picture like I've done here, and draw a line between the 2 points, get a feel for how big the distance might be. And then the idea is to make a right-angled triangle. Making a right-angled triangle including these 2 points. So something like this. Down, and there's the right angle. Now we can see from the chart that the distance, let's call this corner C, that the distance AC is the difference in the x coordinate, which is 4 minus 1, which is 3. The distance BC is simply the difference in the y coordinates, which is 4 minus 2, which equals 2. Now this is where we have to use Pythagoras' theorem to work out the distance AB. Now we know from Pythagoras' theorem that AB squared, the distance of the hypotenuse, is AC squared plus BC squared. So if we put in some values, we get AB squared equals AC squared, which is 3 squared, plus BC squared, which is 2 squared. Simply work those out, which is 9 plus 4, which is 13. So AB squared, the square of the distance we're after, is 13. So we know therefore that AB must be the square root of 13, and that's the answer. Now I would probably leave the answer as the square root of 13. It's a bit neater, but if you've got a calculator with you, you can work that out, and it comes to about 3.61, and that's the final answer. And the same principle would hold in 3 dimensions. You would just have to include a z coordinate there. So in the general situation, we have 2 points, P and Q. The distance between P and Q is going to be the square root, and we use Pythagoras' theorem, which always means we've got squareds of distances, but the square root of the difference between the 2 x coordinates plus the difference in the 2 y coordinates. But you do need to take special care with x and y values that are below the x-axis or the y-axis.